A very good evening to everyone, and today we discuss about the in vivo embryo production, uh, what is also known as the commonly also known as the multiple ovulation and the embryo transfer. Multiple ovulation and embryo transfer, the interest on multiple ovulation and embryo transfer was initiated uh, in the 19th century when European dual purpose breeds were in great demand. And initially, it was difficult to transport the animals, so there came the idea that we should transport the embryos instead, right? So that created interest in the multiple ovulation and embryo transfer in cattle, particularly in cattle. Now, first of all, let us discuss what is embryo transfer. The embryo transfer involves the removal of an embryo from a female and of a superior genetics and the placement of the embryo into the reproductive tract of a female of average genetics, right? So that is the embryo transfer or inducing, and it involves the induction of multiple ovulation by the exogenous administration of hormones, so that multiple ova are formed, and when you inseminate the animal, multiple embryos develop, and then one recovers those embryos outside and transfers them to the animals with poor genetics, right? Now, the goal of embryo transfer is to obtain the maximum number of genetically superior embryos in a minimum amount of time. So, that is the goal of embryo transfer. Then, the purpose, why should we obtain the uh, embryos from a large from a single donor? Uh, we have an outstanding female and we want the progeny, maximum number of progenies, by using this female with a superior male. And then the second purpose is to transport genetics across long distances. And then production of twins by embryo splitting, that is another purpose of embryo transfer. Now, what is the mandate? Really, a mandate for embryo transfer could be the production of outstanding bulls. And embryo transfer can never replace artificial insemination, and it will only supplement, it will provide you with the best bulls so that you can use them for semen collection and artificial insemination. Then, what are the benefits? The embryo transfer allows the production of many offsprings within a year from a single cow, which will not be possible otherwise, because then a cow will produce only one calf a year, because of the gestation period is around 9 months in cattle. So, ET allows the production of many offspring within a year from a single cow. The it improves the genetic potential, it improves the milk production, and it improves the weaning weights as well, right? What are the limitations of embryo transfer? It is expensive, it requires new skills and training, and a lot of work to do. You have to superovulate the animal, you have to administer a prostaglandin, then you have to inseminate a animal, and then after 7 days in cattle, you have to recover the embryos, evaluate those embryos, synchronize the recipients, and then transfer the high quality embryos to synchronized recipients. So a lot of work is there to do. And the most important limitation of embryo transfer is the highly variable ovulatory response. A cow may give 10 embryos, it may give 50 embryos, it can give 100 embryos, and the same animal may even give zero embryo. So, the report from Battridge and his associates, they say that only 30% of the total animals you use for superovulation will provide you quality embryos. So that is a highly variable ovulatory response. When you are administering a exogenous FSH, the response is highly variable, and that is a limiting factor. Now, this is the history that first successful embryo transfer performed by Walter Heap in 1890 in rabbits, and in cattle, first successful superovulation was performed by Cassida in 1940, and the first successful uh, embryo transfer calf was born in cattle by the work from Willett and his associates in 1951, and the first calf was born, buffalo calf was born in 1983 by the work of Drost and his associates in the United States. Then in India, the first ET calf was born at National Institute of Immunology, New Delhi. First buffalo calf at Sabarmati Ashram Gosala, Bidaj. First camel calf at NRC on Camel, Bikaner. And Rajasthan's first ET calf was born at CVS, College of Veterinary and Animal Sciences, Bikaner. Now, this is the data from uh, the embryo transfer data and total production of in vitro derived and in vivo produced embryos in 2019 in cattle according to region. You can see the most of the embryos were in North America, maximum number of, then followed by South America, and then Europe, and Oceania, and then Africa. The data for Asia was not available till this report. Thibier and his associates published this data, but the data for Asia and especially India was not available. Then the government of India has started under the Rashtriya Gokul mission 20 embryo transfer technology centers, and a proposal of 19 centers have been approved so far by the Honorable Minister in 2018. Now, these are the components of embryo transfer. How embryo transfer or multiple ovulation and embryo transfer is being done. First, you have to select the donor. It should be of high genetics. You have to superovulate by administration of follicle stimulating hormone. And by the end of superovulation, you administer a dose of PG. So the donor comes into estrus, and then the after day 7, you inseminate the animal when it is in estrus. On day 7, the embryo is collected by flushing. The embryos are evaluated and then transferred to the recipients. So this is the basic. These are the basic components of embryo transfer. The extra embryos that are recovered can be cryopreserved and kept for further use. Now, for donor selection, it should be of proven fertility and high milk yield. These are the requisites for a donor to be selected for superovulation and embryo transfer. As far as the recipient is concerned, it should have high fertility, but maybe of low genetics, right? Now, what is the mechanism? We generally administer the dose of the follicle stimulating hormone starting from day 8, 9, or 10. Now, usually cattle have two follicular growth waves, and you can see here from the pool of follicles, the follicle is selected to grow, become the dominant, and rest of the selected follicles they undergo atresia for the first and the second wave as well. The dominant follicle of the second or maybe the third follicular growth wave in cattle reaches the ovulatory size and ovulates, and rest of the follicles they undergo atresia. So in superovulation, what is being done? That this is a three-wave follicular growth wave of cattle, and then in superovulation, what is being done when we administer the follicle stimulating hormone on day 9, 10, or 11, and then the exogenously, then the FSH sensitive pool of follicles that would otherwise undergo atresia, rescued from atresia, they reach the ovulatory size and they ovulate. So multiple ovulations occur and multiple embryos may be formed. Now, these are the superovulation protocols. It may involve the use of porcine FSH in a decreasing dose schedule, because even the world's purest follicle stimulating hormone have some contaminating LH. So, and higher doses of LH during the later stage of growth of the follicles may affect their reaching the ovulatory size. So FSH is administered daily, morning and evening, because the half-life of purified FSH is very less. So it is repeated every 12 hours for 3 to 4 days in a decreasing dose schedule. And then at the one day before the last dose, a prostaglandin is administered, and when the animal is in estrus, artificial insemination is being done, and then after day 7 of insemination, the animal is flushed to recover the embryos out, and then they are transferred, they are evaluated, and then they are transferred to the recipients. A approach could be, if you are not aware of the stage of estrous cycle, approach could be administration of a progesterone releasing intravaginal device, and uh, 5 days after this device you can just start the 3 to 5 days after this device you can just start the superovulation protocol. Then ECG has been used. It's a cheaper source, but it has got a longer half life. So it may lead to more number of unfertilized ova. It may lead to ovulation at different times, and that may lead to fertilization failure. So when you recover the embryos are unfertilized ova, or maybe they are on a lower stage. Some have reached morula, whereas others are still on the 2 to 4 cell stage. So this is the problem with the use of ECG. Then the embryos, this is the picture showing artificial insemination being done, and then one need to check the ovulatory response before recovering the embryos on day 7, and this can be easily being done by transrectal palpation or transrectal ultrasonography, visualization of the corpora lutea, or palpating the corpora lutea on the ovarian surface. Then mm, these are the mean ovulatory rates, mean transferable embryos recovered, and these are the reports which justify all this. Then the laboratory instruments that are required, you need some laboratory instruments, say for example the pH meter, the laminar airflow, the stereozoom microscope, the weighing balance, and then you may need a deep freezer, water bath, and hot plates, ETO sterilizer. Now, how embryos are recovered on day 7? The animal is administered epidural anesthesia, and a cervical dilator is passed, and then a Foley catheter like this one is passed into one of the uterine horns, and by passing air inside, the bulb is inflated. So this becomes fixed, and then we attach a Y junction tubing, and this Y junction tubing is attached to it, and DPBS is passed inside and recovered back. There are many other types of infusion catheters, continuous infusion catheters, or you can use the Foley catheters. And then while recovering, you can see here how the catheter is fixed and fluid is going inside and coming out. And when the fluid, these are the media, embryo flushing media. It is usually Dalbecko's phosphate buffered saline. And when the recovered fluid is coming out, we usually attach it to an embryo filter, so that the more amount of fluid recovered goes out, and only a small amount of fluid along with the embryos remain, right? So, and these are the micropipettes. You can, for handling embryos, you can use a micropipette, you can use a embryo exhorter. Some may even use a syringe and a needle. Then the embryos have to be examined under a microscope for their viability. And this is the chart. It's showing the different stages of the embryo: 1 cell, 2 cell, 4 cell, 8 cells, 16 cells, then morula, and then blastocyst. Then there are certain media, maybe DPBS plus holding media. You have to add more amount of bovine serum albumin, and the you can you can visualize the embryos using the Petri plates, and then embryos are filled in straws. Uh, First, a column of medium, then a air bubble, column of medium along with the embryo, again a air bubble, and then a medium, and then they are sealed. Or maybe if you want to transfer them immediately, you need to transfer them using the embryo transfer gun. Even you can use the AI gun and transfer the embryos. For transfer of the embryos, they should be transferred to the horn ipsilateral to the CL bearing ovary, uh, and then you have to wait. The pregnancy rates have been 54 to 68% in Europe and America, as reported by Hessler, and 38% in cattle, 27% in buffalo, as reported by Mishra in India. So these are some of the pictures of how we. So this donor, it yielded a lot many embryos, but they were not of a good quality. Then embryo preservation: embryos can be kept at room temperature for 2 to 4 hours, at refrigeration temperature for 1 to 2 days, or they can be cryopreserved. Then embryo preservation by vitrification is a method now being very commonly used in many places, and vitrified embryos can be easily transferred post thaw. Otherwise, the other procedures, you need to pass the embryos through many other things. So here are some of the books that we suggest for your reading: The Laboratory Production of Cattle Embryos by Ian Gordon, Controlled Reproduction in Cattle and Buffaloes by Ian Gordon, Training Manual for Embryo Transfer in Cattle by FAO. You can read these manuals if you want to know uh, in detail. Otherwise, you need not to read these. Hope this information on embryo transfer and superovulation and embryo transfer, or multiple ovulation and embryo transfer, was useful. See you in the next class. If you wish we continue with these classes, or we bring more videos for your interest, kindly share, subscribe the GNP Sir channel. Kindly give your likes. Kindly go to our GNP Sir classes official YouTube channel, wherein we are sharing videos for JRF aspirants and aspirants of different veterinary exams. So you can watch those videos if you are preparing for any veterinary exam, and you can learn things there uh, for no cost. You can even download the GNP Sir classes app, wherein we have placed a lot of free material, and you can watch them. See you. Uh, have a nice time, and see you again in the next class. Bye bye. Right.